So next, of course, after double integrals is triple integrals. So here, let's sort of do a little comparison. So with double integrals, the idea was to consider a grid in the xy plane and think about a rectangular prism over each of those grid squares. With triple integrals, instead of rectangular prisms, we'll consider cubes. So this time, we're thinking of a small change in the x direction, the y direction, and the z direction. And that will lead to a triple integral. And the limits of integration will describe the region, the solid region that lives in 3 space that we're interested in. So the first thing to think about is the region itself. Don't worry too much about this function that we're going to integrate. Instead, think about the region over which we want to integrate. This time, this region is in 3 space. So it's a little more difficult to draw, so let's see what we can do. So the x values are going to go from 0 to 2, so I'm thinking of x values along here, and then the y values go from y equals minus 1 to y equals plus 1, so we're thinking about all the y values along here. So far we're up to a region in the xy plane that looks like that rectangle, and then finally oh no, that should be a z. The z values are going to go from 2 to 3. So we're going to go from z equals 2 to z equals 3. So in the end, let me see what I can do to draw this. We're going to integrate over a rectangular box that lives in 3 space. Its shadow in the xy plane goes from x equals 0 to x equals 2, between y equals minus 1 and y equals 1, and it's all been lifted up into the z direction. Okay, so then at that point, writing down a triple integral is straightforward because it's a nice rectangular box. So we're going to have 1, 2, 3 integrals. We're going to integrate x squared plus 5y squared minus z, which isn't really that important at this point. And then let's work from the outside in. So dx, the x values, go from 0 to 2, and then the y values go from minus 1 to 1, and finally the z values go from 2 to 3. And I'll go ahead and integrate that on the next page. So to integrate this, the innermost integral is with respect to z. So we're going to integrate this integrand with respect to z. And when we do that, we'll get x squared z plus 5y squared z minus 1/2 z squared. And we're going to evaluate that from 0 to 3. And then the rest we're just going to copy down for now. Sorry, I'm trying to save space, but I don't know if this is going to work out. Okay. So think about what we're going to do. We're going to plug in z equals 3 everywhere we see z, and I noticed that I wrote a 0 down there. That should have been a 2, of course, from this 2. And then we're going to subtract and plug in z equals 2. I'm going to let you check that, and here's what you do, what you get once you plug in those limits of integration. So we plug in 3, we subtract, we plug in 2, and if you do that, you get x squared, and you simplify, of course, x squared plus 5y squared minus 5/2, and then we're going to need to integrate with respect to y and then with respect to x. So in the next innermost integral, we're going to integrate with respect to y. So I'm going to integrate this with respect to y. And let's see what we get. We get x squared y plus 5/3 y cubed minus 5/2 y. And now we're going to evaluate between minus 1 and 1. So we're going to plug in y equals 1 everywhere we see y. We're going to subtract and plug in minus 1 everywhere we see y. And after you do that and you simplify, you should be left with an integral just with x's, and in fact what we'll get is 2x squared plus 10 thirds minus 5. And finally we're going to integrate that with respect to x. Now we're down to a simple integral with respect to x, and so we get 2 thirds x cubed minus 5 thirds x. I did a little bit of simplification, and we're going to evaluate from 0 to 2. We plug in the upper limit, 2, we subtract plugging in the lower limit, and I think you get 16 thirds minus 10 thirds, which is equal to 6 thirds, or 2. Okay, so I did that pretty quickly. You should go back and check that that I did the right thing and that you can do it yourself. So check it or work another example that's in WebWorker in the book.